Welcome student to the properties of limit. In the previous videos, we saw how we can find the limits of many examples where we do factoring and conjugate. In this part, we want to see how we can do properties of limit. Now, suppose we have two functions, f of x and g of x, and we find that the limit of f is L, the limit of g is k. We have many questions we need to ask ourselves. For example, what happens if we need to find the limit of f of x plus g of x? Well, the answer, as expected, the limit will be distributed, and the answer will be just L plus k. So that gives me a very nice way to think of limit, is I need to finalize the first one, finalize the second one, and if there is a plus, just keep the plus. Same thing for if we have multiplication, it will be just L times k. Now, what happened if there is a number in front of the function? This number will go outside, so it would be c times L. Same thing if here is a division, we just divide them, and same thing if we have nth root or any power, it will be just the same thing. We just need to focus on the function, keep everything is the same. Now, if there is no x and we are trying to find the limit, the answer will be the same as the constant c. And if we have x goes to a, xn, we just need to plug a instead of x, and that will give me a number. So those are some properties of the limit, which we can find them very easily in our mind. Let's see one example about that. Now, suppose we need to find this limit. So as usual, we do a direct substitution. So we plug in the number -3 squared. Now, if we do that, this will just give me 0 over 0 to the power 104, which is again undefined. Once we have 0 over 0, this is undefined. Now, how we will solve this question? We will solve it exactly the same way we do it before. Just ignore 104 for now, which means take the limit inside. And that's what we will solve this question. So the limit what I will do, I'll now focus with only the function. Keep 104, it will stay there for as long as we want it to be. So this I just can write it down here. Now, how do we find such limit? Remember, this is a rational function, polynomial over polynomial, so we need to factor this one. Factor it using the calculator, mod 5 3. So we get x -3, x plus 3. I have x plus 3. If everything is correct, at one point I should have cancellation, and that's exactly the cancellation. So I will get just limit x goes to -3. And now, if we just write a -3 down here, it will be 16104. And that's the final answer, because it's a number. It's a huge number. It's a very small number, but it is what it is. This is the number that we get. So that's how we use the properties of the limit, that we can take the limit inside, finalize whatever inside, keep this number and the power. Let's see a question where we have kind of application. Suppose we have a product and the profit function, the money that we will gain of selling this product, is given by this function. We need to find the limit as the number of a product approaches 40, how much my profit will approach. So that means we need to find limit x goes to 40, p of x. Now this is, we can do it step by step, or we can just use direct substitution. So the best way, we just need to plug in 40. Usually we plug in 40 with a different number. If we get a number, that will be the limit. Otherwise, it will be 0 over 0, and then we have to do factoring and all of that. Now, if we have the calculator, all what we need to do is plug in the number. We will get in dollars, because remember the profit will be 320, and we just do it in dollars. So that will be the answer for this part. By this, we did one application of how we use the limit in a profit of a product. And remember, the quantity will approaches 40, so the profit